Yeah.
Okay, so it's recording now. So starting with question 3, which hypothesis involves equality or the equal sign? So I chose the null hypothesis.
Okay.
Everyone okay with that? Hello?
Right.
Sorry, I was on mute. Yes.
Okay. Someone want to get the next one?
I'll read it. P-value of the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer the next question. Remember that the p-value is the probability of obtaining a sample statistic at least as. Wait, I'm just reading the exact same thing, but okay.
Yeah.
When computing p-value, which hypothesis do you assume to be true? Null hypothesis or alternative hypothesis? Alternative, right?
It's the null hypothesis. So the null hypothesis is the status quo, and you always assume that the status quo is correct, or what is assumed is correct, until you prove otherwise.
At least as extreme as the one that was actually observed. Okay. Maybe I misunderstood the definition then, but.
Yeah, so when you are computing the probability of the hypotheses, you always assume the null is true.
Gotcha.
Anybody wants to get the 5th one?
Okay, I read it. Information. Suppose the null hypothesis is mu equal 10. Use this information to answer the next 3 questions. Question number 5. Which of the following represents the alternative hypothesis for a two-tailed test? Okay. The number 3.
Yes, that's correct.
Equal 10.
Yeah.
Because we are looking two-tailed. It's not greater, not be less, should be different.
Yeah.
Okay, for number 6, which of the following represents the alternative hypothesis for a left-tailed test? Okay, the left one should be, okay. The first one?
Yes.
Because must be less than.
So did we say it was the first? Less than?
Yes, it's the first option.
The first option. And for number 7, which of the following represents the alternative hypothesis for a right-tailed test? The option with greater than.
Greater than 10.
The second option.
That's correct.
Okay.
So we're Okay, so for the next question, it says, remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or alpha. Use this information to answer the next 2 questions. So number 8, which relationship would result in failing to reject the null hypothesis? And that is the first option, when p-value is greater than that alpha sign.
Yep.
For 9.
Did we lose?
Huh?
Did we lose Hannah?
I think we did.
Yeah, we lose Hannah.
Yeah.
She was having issues with her internet, so maybe.
Yeah, that's what she said. So for number 9, For number 9, it's the opposite. Which relationship would result in rejecting the null hypothesis? That's when the p-value is less than that alpha sign. I can't remember what that sign stands for. Do you remember? No, but what it's that number. I can't remember what it means though.
Level of significance.
There you go. That. Mm-hmm.
Level of significance.
Okay, I'll read the next one.
Thanks.
An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim was about $1,500. They are concerned that the true mean is actually higher than this. Use this information for the next 2 questions. Which of the following would be the appropriate alternative hypothesis, or level of significance? Average claim is equal to, average claim is not equal to, average claim is greater than, average claim is less than. We're saying alternative hypothesis,
Mm-hmm.
so it would be the not equals, right?
It's actually greater than. So if
The
you
last
see,
paragraph mentioned that is higher than.
yeah.
Wait, sorry, can you repeat that?
So the null hypothesis is it is equal to what they think, right? They think that the average claim is 1,500, so that's the null. The
Yeah.
alternative is what they're fearing is that the average claim is actually higher than 1,500. That's the alternative.
Because that's what they're concerned about.
Yeah, that's their hypotheses. That's
Gotcha.
what.
Yeah.
Yeah.
Okay. So then going into 11, which of the following would be the appropriate null hypothesis? So that would be the standard quo, or equals 1,500.
Correct. Yeah.
Okay.
Okay. So the next one says the insurance company randomly selects 40 claims and collects a sample mean of 1,650. Use this information to answer the next 3 questions. So 12 says the insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? And the options are, it is a good assumption since the sample size is large. It is a good assumption since the sample size is small. That's false. It is a good assumption since the population is normal. We have not read that it is normal. It is not a good assumption since the population is not normal. We have also not read that it is not normal, but we have read that it is more than 30, which according to the central limit theorem, that's large enough.
Yep.
Okay.
True.
And 13, what theorem or law
Just answer
justifies
the-
your answer? That's the central limit theorem.
Yep.
Okay. Someone else want to take the next one?
Which of
Question
the-
14.
Oh,
Oh,
sorry.
sorry.
Go ahead, Paul. So
Okay, thank you. Which of the following is the test statistic as defined in this lesson? X bar, C, S, or N? C.
Yeah. Now, in the next 3, I had trouble with. Actually, the next 4, they're all related to the information that's here. I got all 4 wrong. It says the historical mean of sales receipts at a grocery store is 150 with standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the hypothesis. The null is that the mean is equal to 150. The alternative is that the mean is less than 150. She will use a level of significance of 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes a a mean of 100, or an observation mean of $144. What is the Z-score associated with this test? So I did the same formula that we've used in the past, but I think I did not understand the material in this lesson because I got it wrong.
Yeah, so where the formula that includes the level of significance.
I looked for that and I think I missed it. The level of significance.
I'm looking.
Okay, let me check.
¿Me prestas algo para escribir? Para ver cómo le hacen ellos.
Yo sé, gracias. So the H is the kind of the, I'm not seeing thing where it goes.
Aquí pongo. ¿Están sucios? No, cuando terminamos lo vamos a poner allá afuera. Yo voy a hacer lo que tienes tú. Ya, güey. ¿Estás en tu cama?
So would we calculate the Z-score without even thinking of the level of significance?
That's
Or,
what I thought.
or does the level of significance, because essentially if the p-value is within the level of significance, then it's essentially ignored, right? It's treated as if it was the same as the mean. No? Is that
No, the level of significance just allows you to
reject
accept or reject.
Yeah. Okay. Yeah. So then how does it go? How does that affect the Z-score though?
I don't think it affects the Z-score. You use the level of significance after you get the Z-score and the p-value.
So then were you using the Z-score using the full method, the more advanced method that includes the
sample size?
Yeah, the sample, the root cause of or the root square root of the sample size?
Yeah, so unless my math is wrong, so I did 144, which is the alternative hypothesis, minus the mean, 150, over 40, which is the standard deviation, over 36, the square root of 36.
Which is 6.
The square root of 36, I think. Where is my phone? Oh, sorry. So let me see. I'm gonna try doing it again just to make sure, but I got it wrong. So 40 over 36 square root. So yeah, below I get 1.111 forever. And then at the top, 144 minus 150 is -6.
Wait. Minus 0.9.
Minus 0 what?
.9. 0.9, sorry.
Where did you get that number from?
Okay, using the formula X bar 144, the mean 150, the standard deviation 40, and N equals 36. And I, 144 minus 150 in the numerator divided by the standard deviation divided by square root of 36. And my result is minus 0.9. I have a small Excel here and with a formula.
Yeah, I have the same thing as you.
As Paul?
Yeah, as Paul.
How? 144 minus 150.
All right,
Don't
so
forget the parentheses.
Which
Divided by,
parentheses?
you have to do the square root first,
Uh-huh.
which gets you to 6, because 6 times 6 is 36. So 40
Yeah.
divided by 6 is 6.66 repeating. And then you're doing negative 6.
Mhm.
Oh, you are right. Okay, 40 divided by 36.
So you get negative 0.9.
Okay.
Yes.
Yeah, then that's why I got it wrong. So 40 divided by 6 equals 6.667 over 6 divided by 6.667 equals 0.89.
You only round to the 3 decimals at the very end. So if
Okay.
you actually do 6 repeating,
Uh-huh.
it's just 0.9.
0.9. Okay.
0.9.
So 0.9 is the C-score, negative 0.9.
Yeah.
So then when you put that into the applet, well, wait. So that's the answer already to question 1988. 15. Okay. So then what is the p-value associated with the C-score? So they're just asking what's the probability that a random number will actually be less
Than?
than 144?
Wait, is it less than for this one?
Actually, it's less than 150. So do we have to calculate? I don't know.
We need to use the applet.
Uh-huh.
Put the C-score on the left side minus 0.9. And the area is 0.1841.
That's the p-value or that's the probability?
They're the same thing.
Mm-hmm.
Oh.
Yep.
Okay, so 0.184.
Mm-hmm.
Yep.
So now the next question, what inference would you make about the null hypothesis for this problem? And that's where you would use that number, the 0.05. So when the p-value, you use those rules that we used to answer the questions before, when the p-value is less than that alpha number, then I can't remember what the rules are, but they're up there. Oh, when the p-value is greater than, then you reject the null hypothesis.
Yeah.
When the p-value is less than, never mind, it's the way backwards. When p-value is greater than, you accept the null hypothesis. When it is less than, you reject the null hypothesis. In this case, the p-value is greater than.
Yeah.
So
Fail to reject.
yeah. So you fail to reject the null hypothesis.
I don't know why they do a double negative instead of just saying you accept the null hypothesis.
Yeah.
Just accept or reject rather than fail to reject.
Well, what they're saying, and the rating was a little bit, I think, more complex for my level of understanding, but they were saying that you really never accept the null hypothesis. You can only try to prove that it's wrong, but you don't just accept it, even after you have gotten enough evidence or something like that. I can't remember.
Yeah.
And that's why they use that wording, you fail to reject. Okay, so what is your conclusion for this problem? The first option, we have insufficient evidence that the true population mean is 150. We have sufficient evidence that the true population mean is 150. We have insufficient evidence that the true population mean is less than 150. And we have sufficient evidence that the true population mean is less than 150. I want to say we have sufficient evidence that the true population mean is 150.
Is 150?
Huh?
Is 150?
Yes. And the reason for that is our answer before is we fail to reject the null hypotheses, and the null hypotheses is that it is equal to 150.
Mm-hmm. Yeah.
But we're talking about, sorry. But we're talking, the question doesn't mention null hypotheses, right?
Actually, you're right, it does not.
So I think we have sufficient evidence that the true population mean is less than 150 because we failed to reject the null hypotheses, which means we accepted the alternative hypotheses, which was that it was less than 150. And since we have a sample size of 36, isn't that sufficient?
If we fail to reject the null hypotheses, then we're basically accepting that it is equal to 150. Right, Paul? I don't know.
No, the null hypothesis is that the status quo is that it is equal to 150, and we failed to reject that.
Exactly.
Oh, so yeah. So, man, the way they worded it is so confusing.
I know, it's
so then we essentially, in my mind, I'm just going to say it this way. We accept the null hypotheses.
Yeah. That makes sense to us, too.
Jeez, okay.
Yeah, it's complicated, yeah.
But that seems contradictory to what we found. 36 receipts and the average is 144.
I know. And what they were saying in the chapter is that, you know, you can't just use that very superficial evidence or that very superficial data to make conclusions.
Mm.
And that's why you do this test. It's a weird chapter.
Yeah, this one's...
Okay, so we're almost done.
All right, so we're saying, sorry, that it is we have sufficient evidence that the true population mean is 150, or the second option.
Yes,
Well,
I actually had chosen. I already turned in my foot fell asleep. I had already turned in my first attempt, and I had chosen the last option, and I got it wrong.
Okay. Okay. I'll read the next one, I guess. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? Type 1 error is committed when we reject a null hypothesis that is in reality true.
Yeah.
Yeah, that's true. Error type 1.
Okay. 20. We all agree with that, by the way?
Yes.
Yeah, I agree.
Okay. 20. A researcher decided that instead of using a level of significance of 0.05, he will use a 0.01. Which of the following will be true? The probability of a type 1 error will increase. The probability of a type 2 error will increase. The probability that the null hypothesis is true will decrease. His experiment will be more scientifically valid. Let's see. It would be the probability of a type 1 would increase?
No, it's the second option. So what they
Type
were
2.
saying, what they were saying in the chapter is that, you know, so you are actually the one who sets this number, the chances that you can get it wrong, let's say. And they're saying, well, why don't you just set it up to 0? That way you will never get it wrong. Well, that's also an error, because if you do that, then you may actually not reject a high. Well, you will not reject a hypothesis that will actually be wrong because you have set it to 0. So you want to have a good balance. And 0.05 was a good, they said was a good chance that you would get it right or something like that. I can't
remember. So by lowering it, because when we're comparing whether we accept it or not, we're always doing it. Is it greater than the level of significance or lower? And by lowering it, we make it easier to be greater than. So then the probability of type 2 increases.
Yes.
Okay.
And I think question 21 was a trick question. It says if that number, the alpha number is 0.05, compute the probability of committing a type 1 error. And I mean, it's 0.05. They're already giving you the answer.
Because it's 0.05, that's the threshold.
That's a probability.
Yeah.
Yeah.
It's the same number, 0.05.
Yes.
Because
those tricky people.
Mm-hmm.
Yeah.
I'm not sure about question 18.
18.
Yeah, the conclusion for the problem, because the question is, let me check again. Because the sales, the store manager, suspects that the average has decreased. And our answer is regarding
You're right.
A number. Our answer should be less something.
Yeah.
If you said that you chosen in your first chance the last one and is wrong, probably the correct should be the third one.
That makes sense. Because we're not necessarily,
Since that's the alternative hypothesis we're testing.
Yeah, because we're not necessarily, just because our test didn't prove our alternative right, that doesn't mean that we're going to accept the status quo.
Yeah.
Which is 150. So yeah, you're right, Paul. I think the third option is the best one.
So, Anna, don't submit yet. I'll submit this one and fall on the sword real fast and see if that's correct, since you've already submitted once.
Okay.
%. Good catch, Paul.
Okay,
yay.
Good.
Awesome. Thank you, everyone.
Thanks, everybody.
Bye.
Bye.
Bye-bye.
How do you